Hi everyone, the midpoint and distant formulas is what we're going to be learning about in this section. So let's get started. So here are some formulas and definitions that you'll need to know for the midpoint and distance. The midpoint is the midpoint of a linear segment, and this is the point that divides a segment into two congruent segments. Congruent segments are segments that have the same length. And what we can think about with this is here's my segment. I have my two endpoints, A, C, and my midpoint would be that center point we can call B. So as this definition mentioned, we have two congruent segments that the midpoint makes up. There is a formula for the midpoint to find the midpoint, and that is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. You will be using this formula to answer problems. Along with finding the midpoint, we also will need to find the distance, and you can use coordinates to find the distance between 2 points or the length of a line segment. And below we have the formula for the distance, where it's the square root of x2 minus x1 squared plus y2 minus y1 squared. So in this section we're going to be working with both of these formulas to help find the midpoint and distance of certain points. Our first example, they're asking us to find the coordinates of the midpoint of EF with the following endpoints. We have E is -2, 3, and F is 5, -3. So if we think about this, here we have E with -2, 3, and we have F with 5, -3. So we're going to use the midpoint formula, which is M equals beginning parenthesis x1 plus x2 divided by 2, y1 plus y2 divided by 2 to help us solve this. When I'm looking at my E and F, we can label these points. We can call -2, 3 x1, y1. 5, -3 we can call x2, y2. So with this set up, let's plug this into the formula. x1 is -2 plus x2 is 5 over 2. My y1 plus y2, y1 would be 3 plus y2 is -3 divided by 2. -2 plus 5 is going to give me 3 over 2. 3 plus -3 gives me 0 over 2. Can we simplify this? For the first one, 3 over 2, we cannot, so we can leave this as 3 over 2. For my y, that would simplify to 0. So my midpoint for this question is going to be M, for midpoint, equals 3/2, 0. And that's where the point would fall for the center, for the midpoint. Example number 2, it says S is the midpoint of RT. R has coordinates -6, -1, and S has coordinates -1, 1. Find the coordinates of T. Let me draw a line to help you see this, because this question is similar to the last, but it's a little bit more involved, because here they're giving me one endpoint. In the midpoint, we have to find the other endpoint. So here we have R and T, and S is my midpoint. S is the midpoint. R has coordinates -6, -1, and they're giving me S with the midpoint -1, 1. So what we need to find here is T. We're going to use the midpoint formula, M equals x1 plus x2 over 2, y1 plus y2 over 2 to help me solve this. So we have my midpoint, which is this. So I'm going to write this out as -1, 1 equals, using the formula, my x1, do I have my x1? I do, that's -6. So my x1 is -6 plus my x2. Do we know my x2? We do not. So I'm going to leave that as x2 over 2, comma, y1, my y1 is going to be -1, plus my y2 we don't know, we can call that y2 over 2. So that's how we would set this up to help me solve this. For solving for x, my midpoint x value is -1. So I'm going to look at -1 and then just solve for my x part of this. So we have -1 equals -6 plus x2 divided by 2. And we're going to solve this now using orders of operation to find my x2. So to get rid of this 2 at the bottom as my denominator, I'm going to multiply both sides by 2 to get rid of my right side 2. These cancel out. So 2 times -1 on the left gives me -2, which equals -6 plus x2. I still need to solve for x2, so I'm now going to add 6 to each side. So -2 plus 6 is going to give me 4, which equals my x2. So what is my x for t? That's going to be 4. Okay. Now let's solve for my y. So looking at the original setup, let me erase this first here. Looking at what I set up with the midpoint values given to me and my r values given to me, we solve for my x with using -1 with my midpoint and this. Now we have to solve for y. So I'm now going to look at my y midpoint value and this set with the y. So I have 1 equals -1 plus y squared divided by 2. We're solving for y2, so I need to first multiply 2 to each side to get rid of the 2 as this denominator. 2 times 1 on the left is going to give me 2, which equals, remember on the right, the 2's cancel, so I have -1 plus y squared. I can add 1 to both sides. 2 plus 1 is going to give me 3, which is going to be my y2. So what is my y value for t? It's going to be 3. So have I found my point now for t? Yes. T equals 4, 3. Our third example, we're now getting into the distance formula. It says, use the distance formula to find the distance to the nearest hundredth from A, which is -2, -2, and B, 4, 3. So we need to use the distance formula, which from the notes is D equals the square root of, in parentheses we have x2 minus x1 squared plus y2 minus y1 squared. We can label my A and B. We have x1, y1, x2, y2. Let me make that a little bit neater here. Okay, so let's set this up. My x2 is 4, so D equals the square root of x2, 4, minus my x1, -2. I can put -2 in parentheses because don't forget, part of the formula is minus x1, so it's minus a negative. Squared, plus my y2, which is 3, minus my y1, which is -2, and we'll square that. Let's first take care of what's in the parentheses here. So we have d equals 4 minus negative 2. This is thinking of, since you have two negatives, they become positive. So 4 plus 2, which is going to give me 6 squared, plus 3 minus negative 2. Think of this as 3 plus 2, which is 5 squared. Now we square each of these. So d equals the square root of 6 squared is 36, plus 5 squared is 25. 36 plus 25 gives me 61, so the square root of 61. Notice how I solved this using orders of operation, and I added these, and everything is still left within the square root sign. At the very end, when I have d equals the value under the square root, for instance, like right here, now I take the square root of 61 to find my distance. So my distance, when I take the square root on my calculator, square root of 61 is going to give me 7.81, which is rounded to the nearest hundredth, and that will be my final answer there for example 3. Last example, here we have a graph showing us points on a grid. Each unit on the map represents 100 meters. To the nearest tenth of a meter, how far is it from the roller coaster to the Ferris wheel? Well, here we have our roller coaster. Here is the Ferris wheel, and we need to find the distance between these two rides. So let's think of our distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. We can label the roller coaster and the Ferris wheel. We can call this 2, 8, x1, y1, x2, y2. So I have d equals the square root of x2 is 6 minus x1 is 2 squared plus y2 is 2 minus x1 is 8 squared. Now let's subtract what's in the parentheses. 6 minus 2 gives me 4 squared, plus 2 minus 8 gives me negative 6 squared. Now let's square each of these. 4 squared is 16, plus negative 6 squared is negative 6 times negative 6, which is positive 36. So we have 16 plus 36 is going to give me d equals the square root of 52. When we take the square root of 52 on our calculator, we're going to get an answer of d, equals 7.21. They want us rounding it to the nearest tenth. So to the nearest tenth would be looking at the hundredths to see if we need to round that 2 up or have it stay at 2. And it needs to stay at 2 since we have a 1 at the hundredths place. So my final answer is D. The distance of this is 7.2 meters.